Good wishes, dear students. In today's class, we will learn about packing efficiency in a face-centered cubic unit cell. In short, that is FCC, packing efficiency in FCC. By now, you all are also very thorough with the formula for calculating the packing efficiency, that is total volume occupied by the spheres in a unit cell by volume of a unit cell into 100. Volume of a unit cell is nothing, volume of a cube. So the formula is equals to A cube because we are considering each edge length to be A. So volume of a sphere formula is 4 by 3 pi r cube, which we have used it in the previous calculations too. To calculate the packing efficiency in a face-centered, we have drawn the picture of a unit cell, primitive unit cell. What's the meaning of primitive unit cell? 8 corners also has a particle in it. Now you will also remember faces stands for sides in a cube. So each cube has got how many sides? 1, 2, 3, 4, 5, 6. I mean 1 at the bottom. So 6 sides are there. Each side will have a 1 particle in the middle of it. So that's the meaning of face centered. So there will be 1 particle in the side. 1 particle here, 1 particle in this side. There will be 1 particle here. If we consider the front side, there will be a particle here. If we consider the side at the back, there will be a particle here. So all 6 sides will have 1 particle in the middle of it. Point number 2. Now we have to calculate the number of a volume of a sphere, we need to know the value of R. So we will consider for calculation any one side. So I am considering this side. If you also remember one more term, you have learnt it in the introduction part of it, face diagonal. So what's the meaning of face diagonal? A diagonal is drawn from one face, that is one side from corner to corner. So if I draw the diagonal here, okay, let's name this cube. So take it as A, B and C and D. So I'm considering only one side, that is A, B, C, D. There is a diagonal. AC is called as a diagonal. If you remember or if you have watched the calculation on a body centered, you will understand the purpose of diagonal in it. You will understand the purpose of diagonal. There I used the same thing to explain the diagonal within the body, so unit of a body cell. Now the same thing I'm taking it to explain to you the purpose of a diagonal or a calculation of the R value based showing you this particular image. So now here what will be the edge length is equals to, the edge length of AB is A, edge length of BC is A. Now we need to know the distance between A and C. If you remember diagonal, when we say there are 2 corners here. So if you imagine one atom to be in this corner, another atom to be in this corner. My sectors are wrong. The length of the sectors are wrong. Understand the concept. And the atom in the middle contributes its whole volume. So you can understand it better from this concept here. Diagonal, if you consider this to be A and this to be the C here. So there is a diagonal drawn from A to C. So there is a sphere contributing one sector in this corner. There is another sphere contributing one of its sector in this corner here. And middle, the atom that is present within the middle of the face contributes its whole volume. So the radius of the sector is equals to R. The radius of the sector is equals to R here. It happens to be the diameter of the sphere. So diameter is equals to 2R. Therefore D is equals to 2R. So how many radius are present here? 1, 2, 3, 4. So I can write this as that is AC is equals to 4R. So we have calculated the value of, diagonal is made up of 4 radius. Now we need to know exactly what's the value of R. So as we have seen it in the previous packing efficiency calculation, let's consider the triangle, that's a right angled triangle that is present, ABC. So in a right angled triangle ABC, in triangle ABC. Making use of the Pythagoras theorem, let's calculate the value of the hypotenuse, that is AC. So what is according to Pythagoras theorem? In triangle ABC, AC square is equals to AB square plus BC square. Therefore, AC is equals to square root of AB square plus BC square. Now what's our AB is equals to, edge length happens to be A here. So that is A square. Edge length of BC is also A square. So it's equals to A square. Therefore AC is equals to 2A square. Taking the square root, we get AC is equals to square root 2. A square gives us A as the answer. So we have got finally the length of the hypotenuse, that is AC is equals to square root 2A. Here we got AC is made up of how many radius? 4 radius. If you remember, you will understand how did we get the 4R values here. Substitute this into here. So when we substitute the value in place of AC, what shall we substitute? Square root 2 into A. Square root 2 into A is equals to 4R. Therefore, R is equals to square root 2 by A by 4. So this is the value of the radius that we are going to substitute here. So we have calculated from one side of the face the length of the diagonal. Substituting the length of the diagonal, we have calculated the value of R. Now let's move on to calculate the volume of the sphere. So therefore, volume of the sphere formula is equals to 4 by 3 pi r cube. So 4 by 3 into pi into, what's the value of r is equals to square root 2 by 4 into A the whole cube. If we expand this one, we will get 4 by 3 into pi into, you also will know square root 2 into square root 2 into square root 2. These two will give us 2 as the answer. This is an explanation here. 2 into square root 2. Substitute here 2 into square root 2 into A cube. Now 4 cube will become 64. Let's simplify the number. 1s are 16s are. Further, when we simplify, 1s are 8s are. So we will get the volume of the sphere is equals to, that is square root 2 into pi A cube by 8 3s are 24. The sums are not over. One more calculations we've got. So this is the volume of the sphere of one side. So face has got how many sides? Cube has got how many faces? 6 faces. So we have to calculate that which you have learnt it earlier. Number of atoms in a FCC unit cell. The formula, if you remember, it stands for NC by 8 plus NF by 2. NC stands for number of atoms at the corner. NF stands for number of atoms within the faces. So how many faces are there? 6 faces are there. The atoms at the faces, do they contribute 1/4 of their part or 1/2 of their part or 1/8? They contribute only half of their contribution to the a particular unit cell. So if you remember the calculation that we have learned, I'm writing it for you to understand. So 8 atoms are contributing 1/8 of their part at the corner plus NF, when we say 6 faces are there. 6 faces are contributing 1/2 of their part. The same thing when we write here. So I will write it as a 8/8 plus 6/2. So when we simplify, what do we get here? We get 1 plus 3 is equals to 4. So number of atoms in a FCC is equals to 4. So volume of one sphere is root 2 by into 2 pi A cube by 24. So multiply it with for the total volume. Therefore, total volume occupied by the spheres in a FCC, face centered cubic, FCC is equals to whatever answers we've got, multiply it with the number of atoms in a FCC unit cell. That is 4 into square root 2 into pi into a cube by 24. Further, if we simplify here, 1s are 6 are. So we get the answer to be square root 2 into pi into a cube by 6. So this is the total volume occupied by the space. Next one, we have, therefore, we will go move into calculate the packing efficiency. Now, what's the formula for a packing efficiency? That's the total volume occupied by the volume of the unit cell into 100. So, the total volume occupied is root 2 into pi into a cube by 6 by total volume a cube into 100. If we rearrange the step, we will get root 2 into pi into a cube by 6 into a cube into 100. Let's simplify the term. A cube and a cube get cancelled. So the value of root 2 is equals to 1.414. Let's substitute. The value of pi is equals to 3.414. If we substitute the value, we will get here, that is 1.414 into 3.14 into 100 by 6. So the final answer comes up to 74%. So this is the volume of the spheres occupied in a face-centered cubic unit cell. So this is how we have to calculate the volume packing efficiency in a different cubic unit cell. May it be a simple cubic or a body-centered or a face-centered. So let's sum up with the final conclusion. If we take the volume of the space occupied in a SC and a BCC and FCC, the percentage of the volume occupied in FCC is 74%, BCC is only 68%, SC is 52.31%. So the volumes are occupied better in a face center than in a simple cubic or a SC unit cell. So in a attractive force is minimum in the simple cubic unit cell and maximum in a face-centered cubic unit cell. Thank you.